Dear students, let's start lecture number 17 on the topic Data Encryption Standard Algorithm, which is normally called DES, and this is part number 2. As I mentioned in my previous video lecture that it is a big topic, so I have divided this big topic into 4 parts. So today I will be discussing part 2 of DES. So let's get started with outline. So first we will be revising data encryption standard part 1, which we covered in our previous lecture. And today's topic is data encryption standard part 2. So in today's lecture, we will be covering expansion permutation. Actually, these are the part of round 1, you see. As I mentioned that DES is consist of 16 rounds. So we will be explaining one round in detail, and rest of the round they are same. So if you understand the working of round 1, you will be able to understand the whole working of DES. So you can see here that as we have discussed plain text and then key transformation, and now today we'll be discussing expansion permutation as box substitution, and then we will be explaining as box substitution with the help of diagram that how it works, and p box permutation, and then we will be having question answer, and then I'll be showing you the references I have cited, and I'll give you assignment at the end. So let's start with lecture number 16, data encryption standard, DES part 1. So these are the general information about data encryption standard. That is, it was developed by National Bureau of Standard NBS in 1970 with the help of National Security Agency NASA, and it was get approved in 1979. And it is a block structure, block cipher. As you know, there are two kinds of ciphers: stream cipher and block cipher. A stream cipher perform operation on a one character at a time, whereas in a block cipher we take more than one character at a time. That's why this is called block cipher. So data encryption standard is taking block cipher. Based on block cipher. So encrypts data in block size of 64 bits. So how many bits data encryption standard requires? It requires 64 bits plain text, and this will be provided you 64-bit ciphertext. So produces 64-bit ciphertext, as I mentioned. Key length is 64-bit, originally consists of 64 bits. 54 bits are used by the algorithm. Where are the remaining 8 bits? As I mentioned in my previous lecture, that each 8th bit of a byte will be used as a parity, used for parity checking. So this will be that will be discarded thereafter. Once it performs parity checking, so that will be discarded. So 8 bits are used solely for checking parity. So discarded thereafter, as I mentioned. So consists of 16 steps. Each one is called as a round. Each step performs the steps of substitution and transposition. So definitely you have to understand what the substitution and transpositions are. So based on two fundamental attributes, substitution called as a confusion, and transposition called as diffusion. So some more detail about data encryption standards. So this is a symmetric block key. So same symmetric block encryption standard. So same key is used for the process of encryption and decryption, and it published by the National Institute of Standard and Technology. It says that DES is a block cipher, and general structure of DES like this. You can see here you will be passing 64-bit plain text, and it will be passed to the DES, and it will convert 64-bit ciphertext, and 56-bit key will be used, as I have mentioned 56-bit, but in a previous lecture, if you remember, this has reduced to 48 bits because this, as I mentioned, that this is the journal key 56 key, and we have to produce 16 sub keys from this 56 bit key, and the size of each sub key would be 48 bits, if you remember. I'll discuss that in coming slides as well. You can see that there as well. So once you receive the ciphertext, now on the receiver side, 64-bit ciphertext, this will be passed through the DES, and DES gives you back the plain text. So this is a general structure of DES. Now you can see here that 64-bit plain text will be passed to initial permutation, and then it will pass to the round 1, and then it will be going through round 2, 3, and so on, and finally reaches to round 16, and then the final permutation is performed, and after that you will get back 64-bit ciphertext. From the plain text you have received 64-bit ciphertext. Here you can see that, as I mentioned, that total we have 64 bits, but each 8 bit of a byte is used for parity checking. So we were left with 56 key, but this is general key. When it passed through the round key generator, it produces 16 sub keys of size 48 bit each. So this will be provided to each round, and then final permutation is performed, and you will get the 64-bit ciphertext. So now initial permutation, as I shown in my diagram, that it happens only once. So nothing but jugglery of bit position of the original plain text. You can see here that you have a plain text of 64 bits, and then you will perform initial permutation. Initial permutation means that you will be changing the bit positions. So here you can see that the first bit is changed to 16, and the third bit is changed to 1. So this is just a jugglery of bit position of the original plain text, and then after that this is converted into LPT and RPT, means left plain text of 32-bit and right plain text of 32-bit. Suggests how the transposition in initial permutation proceeds. For example, IP replaces the first bit of the original plain text. This is an example that first bit is replaced with the 58-bit of the original plain text, and the second will be replaced with the 58th bit of the original plain text block, and so on. After IP is done, the resulting 64-bit permuted block divided into two 32-bit block each, means left and right. So after that, initial permutation process is done. Permutation process is done. After IP is done, the resulting 64-bit permuted block divided into 32-bit RPT and left plain text. As you see that after after the jugglery of bit position, this is divided into LPT and RPT, and then it's passed to the 16 round block. Here you can see that in round 1, you can see here that key transposition is performed. For each round, a 56-bit available. Now I think you know this thing as I explained this thing in the general structure. From the 56-bit key, a different 48-bit sub-key is generated. This is already explained in my previous slide. During each round, using a process called transformation. So this transformation process is done. This 56 key is divided into two halves, each of 28 bits. Here, now you can see here in the transformation, this is divided into two halves, each of 28 bits. These halves are circularly shifted left, one or two. This is one or two position depending on the round. After an appropriate shift, 48 of the 56 bits selected, the key transformation process involves permutation as well as selection of a 48-bit subset of the original 56-bit key. It is called compression permutation. As you know that total we have 64-bit. Then 8 bits they were removed for the parity checking. So we were left with 56-bit. And after that, when we were producing the sub key, when we were producing sub key for the each round, so we will be getting 48-bit key. So this is called compression permutation. So permutation means jugglery of bit position, and compression means that your size is reduced. That's why it's called compression permutation. So let's start lecture number 17. Data encryption standard, as the topic is same, but this is part number 2. So today we'll be discussing expansion permutation and S-box permutation, and then we will be explaining this with the help of a diagram. So expansion permutation, during expansion permutation, the RPT means right plain text is is expanded from 32-bit to 48-bit. Now we have to increase the size, as you know that we have 48 bits, right? So we will be increasing 32, we will be putting 32 bit into 48 bits. So besides increasing bit size from 32 to 48 bits, the bits are permitted as well. Hence the name expansion permutation. As name suggests that expansion permutation means that you will be increasing size from 32 to 48 bits. This happens as well. The 32-bit RPT is divided into 8 blocks. Each consists of 4 bit. Each 4-bit block is then expanded to corresponding 6-bit block. That is per 4-bit block, 2 more bits added. So we need 2 more bits. I'll show this with the help of a diagram in the next slide. They are actually the repeated first and 4th bit of the first and 4th bit that will be repeated as we are increasing the size from 4 to 6. So each first and 4th, this will be repeated. So I'll show that with the help of a diagram. You can see that original right plain text of 32-bit, each of 4-bit size, as you can see. And now this 4 size is increased into 6-bit. Now you can see this is the fourth. This is repeating character for the first one, and for the first one will be increasing the first and fourth, that will be repeated. So you can see that the first is coming to fourth one is coming to the first one, and first one is coming to the fourth to the previous. So that using that we are increasing the size from 4-bit to 6-bit. That's why this is called expansion permutation, right? Firstly, the key transformation process compresses 56-bit key to 48 bits. Then the expansion permutation process expands the 32-bit write plain text to 48 bits. Now the 48 bits is XORed with the 48-bit write plain text, and the resulting output is given to the next step, that is S box substitution. You can see here that key transformation compressed from 56-bit to 48-bit. Now this is 28 bits, and now we have 48-bit key, and then this will be XORed. You see here XORed, and you can see here that expansion permutation, what it does, that expand write plain text from 32-bit to 48-bit, as we have increased 2-bit in each block. So after 48-bit, this will be applied. This will be XORed and provided to S box substitution. So this is how this this expansion permutation is performed. Now, S box substitution process that accepts 48 bits. So now, as you see in a previous slide, you can see that now you have 48 bits. So that accept 48-bit key from the XOR operation involving the compression key and expanded R write plain text produces a 32-bit output using the substitution technique. The substitution is performed by 8 substitution boxes called as S boxes. Each of the 8 S boxes has a 8-bit input and a 4-bit output. I'll be showing this with the help of a diagram on the next slide. The 48-bit input block is divided into sub blocks, and each sub block is given to a S box. The output of the S blocks are then combined to form 32-bit block, while each is given to the next stage of around the P box permutation. You can see here with the help of diagram that you have 48-bit input, and then it will divide it into 6 blocks of each, 6 blocks, 6-bit sub block. So you have 8 blocks, and then this will be converted into S box 1, S box 2, and S box 8, and then we will combine these to get 32-bit output block. Now P box permutation. This is the permutation. You can see that P box permutation. The output of the S box consists of 32 bits. These are performed using a P box. This involves simple permutation, swapping of each bit with another bit without any expansion or compression. This is called as a P box permutation. So as you know that in permutation, what the permutation is, normally we call permutation as the jugglery of a bit position. So you are changing a bit position. So that's why this is called P box permutation. So bit position of the block will be changed. Now we will continue this round number 1 in our next video lecture. For the time being, you start thinking on that if you take any 16-bit plain text and convert into ciphertext using DES, so you will get the experience of that how DES works. These are the sources cited. You can go through these references and find more about this topic. If you have any confusion, you can ask me question anytime on a KCMS or WhatsApp, or you have my email number, email address. You can see my email address shown here. So you can email me and I'll be more than happy to answer your question. So thank you for your uh, thank you for your time. So till next lecture, Allah Hafiz.